Fun with predicting reaction products. My students tend to give me a hard time for calling this fun, but once you get the hang of it, it's really not too bad. So what you're going to do in this worksheet is you are going to determine which type of reaction each one of these is going to be. Notice there's no products to compare it to. You're going to have to look at just the reactants to determine whether it is a synthesis, decomposition, single replacement, double replacement, combustion, or acid-base reaction. So when you go through these, look at your reactants, determine which type of reaction it's going to be. Then, based on the type of reaction, that'll let you know what products you need to make. So let's go through the different types of reactions on your reading material. So let me find these. Here we go. So here are examples of each kind. So if we have a combustion reaction, you're going to have something that has carbon and hydrogen in it reacting with oxygen. So you'll go through 1 through 8 here and determine, do you have any that are a hydrocarbon, carbon and hydrogen, reacting with oxygen? If you do, you're going to label it a combustion reaction. Okay, for type of reaction here, you would put a C. Then, for a combustion reaction, it says that the products will be carbon dioxide and water. So you'll have carbon dioxide and water as your products. Don't ever put anything other than CO2 and H2O as your products for a combustion reaction. All right, a combustion reaction of a hydrocarbon and oxygen will always be CO2 and H2O. And then all you have to do at that point is balance it. Okay, so look for those on your paper and then make sure that you balance your equation after you're done. For a synthesis reaction, you're going to look for two simple substances, typically 2 elements, and then put them together to make a compound. So if you see 2 elements that are reacting together, you've found a synthesis reaction, and you'll put an S for type of reaction. Then you will form a compound out of them. Now, this one happens to form CaCl2, which is what's written here. It won't always be that way. Again, make sure you look up the charge of the positive ion, the charge of the negative ion, put them together to make a proper compound. This is +2 and -1, so it does take 2 of them to make a proper compound. Excuse me. So do check to make sure that your product comes out as an actual compound that could form in this reaction. If you have a decomposition reaction, remember you're only going to have one compound before the arrow, one reactant that is a compound, and it will break up into different constituent parts. So if we have this, it would break up into Al and O2. Don't forget we put O2 because oxygen is a diatomic. So when this breaks apart, it wouldn't just be Al and O, it'd be Al and O2 because oxygen is a diatomic element, which means it'll always be found with something else, or if it's by itself, it'll have a 2 after it. So when you balance it, then you're done. So again, decomposition reaction, break up your parts to make the products. Now, a single replacement reaction, we just looked at on our activity series worksheet, and we already did some reactions like this, so you should be fairly familiar with these. You're going to go in and replace the single element with the part of the compound that it would replace. So Mg is a positive ion, so it's going to replace the positive Li ion. Now in this case it says there's no reaction. All of the reactions on this worksheet are valid. It means every single one of these will work. So you don't have to look back at your activity series to determine if any of these work. They all work. So this whole point of this is not to look up on the activity series. The point of this is to make sure that you can make the products and balance the equation. So single replacement reactions, just replace the part that is the same charge. So positive will replace positive. Here the same thing, positive replaces positive. Make your products and balance it like we did on the other sheet. Pardon me. Next, double replacement. If you have a double replacement reaction, you're going to be looking for precipitation reactions. And in this case, it says there's no reaction, but again, all of the reactions on your worksheet are valid, so you don't have to worry about looking up on the solubility chart whether or not it would form. You are just going to create the products based on the compounds that are in the double replacement reaction. So here, for example, BaCl2 and Na2SO4, you're going to put those together by replacing these two positives with each other. So now Na will bond with Cl and Ba will bond with SO4. Since Ba has a +2 charge, SO4 has a -2 charge, they make a compound. Na has a +1 charge and Cl has a -1 charge, so they form a compound. You must look up the charges of each of your ions before you can make these compounds at the end. Okay, so do be careful on that and make sure you're looking up the charges so that they will actually form proper compounds. The last one, acid base. We had another worksheet where we were identifying these. If it starts with an H for one of the compounds and ends in OH on the other compound, then we have an acid base reaction. And remember, one of your products is always water because this is a neutralization reaction. The hydrogen ions and the hydroxide ions, the H and the OH, will neutralize each other and form water. And then the other parts of the acid and base will become the other compound, the salt that is formed in the neutralization reaction. So if you have an acid, starts with H, and a base, ends in OH, they react together, one of your products will be water and the other one will be the salt that forms from the other parts of the acid and base. So as you go through these, determine if you have a synthesis reaction because you have two small parts forming together to make a larger one. Decomposition, you only have one thing on the reactant side of your equation. Single replacement, you're going to have one element combining with a compound. Double replacement, two compounds coming together. Combustion, you have something reacting with oxygen. In this case, it's going to be a hydrocarbon, something with carbon and hydrogen. Or an acid-base reaction where you have an H positive in one compound and an OH negative in the other compound. Go back to the reading material to help you figure out what's going to be formed in each reaction. Make sure all of your compounds add up to 0, that they cancel each other out, and that you have balanced each one after you made all of the products. I know there's a lot of steps in doing these questions, so if you are still having any problems with any of them after you've given them a try, please make sure you come up and ask for some help.